Welcome back to Unit 11, Grade 12 Mathematics under the CAP syllabus. So today we're gonna be focusing on the sine rule, cosine rule, and area rule. So we are gonna basically be solving any triangle. So of course we're gonna look at the right angle triangles and we look at the Shorter wall that we spoke about in the previous chapter. We're also gonna talk about area rules when you're given two sides and an angle. Then I'm gonna talk about the sine rule when you have a non-opposite pair. Then we're gonna talk about the cosine rule where you've got side, angle, side, SAS, or side, side, which is SSS. Then we're gonna look at 2 and 3D applications. So basically, you can see you can have this angle, this triangle, with side A, B, and C, and the length A, B, and C. As you can see, this angle A, it corresponds to side A. This angle C corresponds to side C. This angle B corresponds to side A. So that's an important thing to notice. Then when we so in this chapter, for example, we're gonna look at the area of a triangle. So we say area of a triangle is equals to half AB sine C, right? So so if you are given this angle C, let me use a different color. If you are given this angle C, then it means you use A and B, right? So that will be, let's say this, for argument's sake, let's say this is 8 and this is 10, and this angle is 30 degrees, just for argument's sake. So it will be half times 7 times 10 times sine C, which is 30 degrees. So if you simplify it, let me take my calculator. From my calculator, if I punch half times 7 times 10 times sine 30, I'm getting 17.5. Let's say these are in centimeters, so it will be centimeter squared, like that. Then there is also this formula. As you can see, it's mostly like derived from the Pythagorean kind of calculations. So in this case, let's say this side, let's say we are calling this side 80 degrees, for example, side A. So if you okay, let me just draw a different triangle so that I don't confuse you. So if you've got a triangle like this, A, B, and C, do you know that this is 80 degrees, right? And you're given your B, let's call it 10, and your C, let's call it your A, it's unknown, we don't know it. Then this one, we can call it 14 centimeters, this one. So for you to find A, let me use a different color. For you to find A, this one, it means you can use this formula. So it will be A squared is equals to B plus C squared minus 2BC cos A. Then you substitute, in this case your B is 10 plus your C is 14 squared minus 2, 10, 14 here, cos 80 degrees. So when you simplify, then you punch it in your calculator. 10 squared plus 14 squared minus let's say in bracket 2 times 4 times 10 times 14 times cos 80 degrees, close bracket. I'll get 247 point. Let me round it off to decimal place. This will be a squared. Therefore, a squared is equals to square root of square root. So it will be 15.73 centimeters. That's how we apply. So these are the types of questions that we're going to be dealing with in this chapter. So let's move on. Our learning objectives are obviously we're going to start by identifying triangles. So decide whether the triangle is a right angled or a non-right angled. So a right angled triangle will be having a right angle here. Then a non-right angle triangle will be something like this without a right angle. For example, this one can be 80 degrees, this one can be 50 degrees, then this one will be also 50 degrees, because remember, total should be 180 for triangles, right? So in this case, you can have like a 45 degrees here, 45. This is just an example. So this will be a right angled triangle, right? And a non-right angled triangle, right? Then we also, based on that, we select the rule, second step. So if it's a right angled triangle like this one, then you can use the Shashota rule, right? If it's not, then you can use area rule, sine rule, and cosine rule, right? Depending on which values are you given. Then you can solve for the unknowns, find missing sides, angles, or areas using the correct formula. Then we're also gonna interpret diagrams, break 2D, 3D equations into useful triangles. Then there's also ability to show working when you are doing these problems. So use the formula systematically and avoid premature rounding. So you follow certain stages so that you can also show the examiner or the marker how you go to the answer. So obviously this is very important. The answer is not only everything. So showing working is part of the process. So you can also check for reasonableness. Angles must sum to 180 and length must be positive. Otherwise, if you calculate and find that the length is minus 10 centimeters, then you know that there is something wrong in your calculations. Or if you add the angles and you get 210, but you know that triangles, they add to 180 degrees, then you see that there's something wrong. So obviously in your working, always check for reasonableness so that you know that you have not done any mistakes. So this is what we're gonna cover under this section, and I believe all will be well. So let's move on. So let's talk about right angled triangles. So we have already done that. The Shashota rule, sine theta is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse, then tan is opposite over adjacent, and we know this is the hypotenuse, this is the opposite, this is the adjacent. Then it works for right angled triangles, right, where theta is the angle we are using for reference. So opposite is across theta, as you can see here, opposite. Then adjacent is next to theta, as you can see here. Then hypotenuse is opposite the right angle. This we have already used the Pythagoras if needed. So we have already covered part of these right angle triangles in the previous sections. So We won't go much on these ones, so let's move on. So let's do a worked example of a right angle triangle. So we are having theta is equal to 37 degrees and the opposite is 16 centimeters, as you can see here, and find the hypotenuse. So